Hello, everybody. My name is Romain Coulon, and I'm very pleased to welcome you in our CCRI webinar on digital transformation in ionizing radiation. As mentioned by Vincent, this webinar is an initiative from the CCRI Digital Transformation Task Group, and the idea is to give you an insight into what is being done in practice on digital transformation in metrology laboratories. To that aim, I will start by sharing with you the discussion ongoing within the Digital Transformation Task Group. Then our colleagues from the Belgian Institute SCK CEN will present us the digital work they carried out at their institute. Our first speaker is Cristian Mihailescu. He made a PhD in nuclear physics and then worked at the Horia Urubei Institute in Romania and at the Joint Research Center of the European Commission. He is now a senior researcher and head of a laboratory at SCK CEN. Cristian will present us the digital workflow at dosimetry calibration laboratory, the LNK. This work is related to the areas of the CCRI sections 1 and 3. Then our second speaker is Leen Verheyen. She is a nuclear engineer specialized in radiochemistry and environmental applications. She used to work in neutron activation analysis and radioactive source preparations. She is now head of the gamma ray spectroscopy laboratory, where she measures mainly environmental samples, but also norm nuclides, control samples from the BR2 reactor, the effluents around the site, food, feed controls, and others. Leen will present us the laboratory information management system at the LRM laboratory. This work is related to the area of the CCRI section 2. Finally, Geert van Woensel is a chemical engineer working at SCK CEN since 2006. He started as a quality engineer, specialized in quality assurance system, and is now quality manager for about 10 years. He committed in transforming the original quality assurance system into the integrated management system established today at SCK CEN. He will present the integrated management system of the SCK CEN that benefit to every domain of the metrology. I will start this webinar by a quick introduction on the challenges related to digital transformation in ionizing radiation metrology. Following the last CGPM, a resolution was voted on the global digital transformation and the international system of units. Following this resolution, the CCRI decided the creation of a task group on this topic, the CCRI DTTG. Our group is composed of representatives from the 3 sections of the CCRI, plus representatives from the ICRU, providing references for quantities and units used in our domain, the IAEA, in charge of the SSDL network, and the Decade Data Evaluation Project hosted by the LNHB. The aim of the group is to advise the CCRI on the SI digital framework on the wider implications of the global digital transformation for ionizing radiation metrology, as well as to act as a forum to exchange information on progress and to create synergies and opportunities for collaboration in this field. So, the CCRI, as part of the CIPM, is a stakeholder committed to work end-to-end with other committees to develop the SI digital framework. This SI digital framework is a network of tools, services, and applications that instantiates the digital SI, assuring that measurements are fair, machine-readable, machine-actionable, and supporting digital metrological traceability. We mentioned here the acronym FAIR, which is a key acronym we must always keep in mind as our driver in digital development. It means that we must work on making our measurement data findable, accessible, interoperable, and reusable. During last year, we had the opportunity to discuss many topics. First, a colleague in secondment at BIPM, Gregor Dudley, introduced to us what is behind the concept of the SI digital framework. Then I presented to the group the digitalization work carried out at the ionizing radiation department. I presented the automation of the production and reporting of key comparison results and shown an example of a machine-readable key comparison data. Then we also get feedback from what is done in other consultative committees. My colleague, Gianna Panfilo, presented to us the API web service developed for the CCL and the CCTF. Her presentation was followed by interesting discussions on the key reference data used in ionizing radiation metrology. This permits us to build a common view on which reference data could be transformed in fair digital data to help metrological traceability for ionizing radiation measurements. Finally, Anna Cristina Lafrati from ENEA INMRI shared her digitalization work carried out in their designated institute for Italy to automatize the data analysis and the reporting through a combined use of MySQL database, Python, and LaTeX. At the end of the day, we will be rich of 3 experiences on digitalization in metrology laboratory from the ionizing radiation department of the BIPM, from the ENEA ENMRI, and now from the SCK CEN. It will be the opportunity to compare these experiences and to provide general recommendations to the CCRI community. We identified 4 main topics where digital transformation is important for ionizing radiation metrology. The first topic is about reference data, including calibration factors, decay data, cross-sections, and so on, that are used in calibration processes. The second topic affects the daily life in a metrological laboratory. It is the automation or digitalization of our measurement processes. The presentations of today will be focused on this particular aspect. The third topic is how we can establish a digital traceability chain where digital calibration certificates will be exchanged machine to machine and toward connected measurement devices. The fourth topic is about the benefit of artificial intelligence in our domain. As previously mentioned, we have already started to discuss the 2 first topics, reference data and digitalization. We must now learn more on the 2 other aspects, digital calibration and benefit of the AI. Concerning digital calibration, I remind you that a conference on digital calibration certificates is coming in February. Concerning the aspect of reference data, the first kind of data is the dosimetry data, providing standardized conversion factors and other parameters used to ensure traceable and accurate dose measurements. Photon dose karma coefficients or neutron dose fluence coefficients are currently made available through the restricted access and human-readable ISO standards. There is no digital formats nor web interfaces to access these key reference data by machines. So we identified as a priority to work on providing digital access to these conversion coefficients. The second kind of data is the decay data, including half-life, decay modes, branching probabilities. The decay data are already formatted in internationally recognized machine-readable formats, such as ENDF, ENSDF, or PennNuc. The decay data are also being made available through web interfaces, such as the DDEP webpage of the LNHB, the National Nuclear Data Center of the BNL, or the live chart of nuclide of the IAEA. These data are therefore already in compliance with many aspects of the FAIR principles, but there is no unique universal reference. Evaluations are provided by many groups. So it's tempting to imagine establishing an authoritative and universal reference for decay data. However, this does not correspond to the practice of metrologists in the field. For many radionuclides, the decay data is not known with sufficient confidence, and the scientific community, including metrologists, is actively working to measure these fundamental values. This must be seen in the context of the evaluation schedule, which requires enough publications to be completed. Meantime, a physicist can make his own evaluation by considering recent publications that were not considered in the last version, which may date back 1 or 2 decades. So it's probably better not to change the current policy, not imposing a specific dataset, but only making general recommendations, such as considering DDEP evaluations in the section 2 of the CCRI. It's the same for cross-section data, describing the interaction of ionizing radiation in a target material. Cross-sections are also formatted in machine-readable formats, such as ENDF, and they are provided by several web libraries. This data is formatted in a way to be processed by Monte Carlo simulation codes. The cross-section data, especially for neutrons, are not well known to imagine establishing a universal unique dataset. In practice, the choice of a particular cross-section data or a particular Monte Carlo code is the responsibility of the metrologist. The analysis of key comparison results is a way to investigate discrepancies between cross-section data or Monte Carlo codes, and it's also a good idea to encourage setting benchmark, allowing to compare codes and data for metrology applications. The digital transformation also impacts our measurement system, where digital electronics are more and more implemented to process the counting signal. This provides access to a level of information hidden in analog systems. This metadata opens the possibility to enrich the analysis of key comparisons. It will notably be possible to assess the specific impact of the digital signal processing on radionuclide standardization. A secondment will be welcome this year at BIPM to start investigate this topic. I have also mentioned that the automation of the laboratory measurement activities is a key topic addressed in the webinar of today. This digitalization changes the work of metrologists. On the one hand, it requires more software and data science skills to be included in the laboratory team. On the other hand, it's a clear benefit with the disappearance of the papers and human handling errors associated with data in papers. It permits to improve the control on the security of the measurement data, all of this leading to an enhancement of the quality system. Now, it's time to move to the SCK CEN colleagues, who will speak about their digitalization experience. Christian, the floor is now yours.
Thank you very much. I call the presentation Digital Transformation at the Laboratory for Nuclear Calibration of SCK CEN. Now it will be a very short an introduction. Then how we arrive to this situation where we are relatively automated by showing the evolution of LNK since the beginning. Then the digital workflow that we have now, and I will also discuss a bit about the application of the integrated management system at LNK, but my colleague Geert will go more in detail with that. And then some challenges and what we can do next. I heard many definitions: digitization, digitalization, or digital transformation. There is not a clear separation between them. Digitization is the process of converting analog data into digital format, with a final goal to have something like paperless laboratory and more data accessible very easy. Then probably the next step in evolution is digitalization, where we improve the process with digital solutions, software, data acquisition, and then we have higher efficiency in our workflow and less risk of errors. And probably on top of the evolution is the digital transformation that can be seen as a digitalization plus, and this is a complete change of strategy with much higher efficiency, nicely integrated apps, user-friendly software. This is how I see it. Okay, it's probably there is not a very clear definition of digital transformation. So in the next slides and also in the presentation of my colleagues Leen and Geert, we'll try to see where SCK stands, and okay, for my presentation, where LNK stands. Did we have a digital transformation or just digitalization? So first, SCK CEN is the Belgian Nuclear Research Center. The name comes SCK CEN from the Dutch and French translation. It's a foundation of public utility. We are located in northeast of Belgium in Mol, and you see the map on the right side, while the two nuclear power plants in Belgium are Doel and Tihange, and Brussels, it's more or less in the center of the country. SCK CEN concentrates the research in nuclear field, and it was created in 1952. We have about 900 staff with a lot of PhDs. Mol, it's in the forest region. So here on the right, you have a view from airplane or satellite. It's relatively old, and the new lab of LNK is somehow on the center of the site. So it's a place where, if you like nature, it's excellent. If you like nightlife of big cities, it's not very attractive. So from about 900 staff members of full SCK, we scale down with a factor of 300, and we end up to the Laboratory for Nuclear Calibrations, only 3 staff members. We are part of the Radiation Protection Dosimetry and Calibration Group, and we are the designated Institute for Metrology of Ionizing Radiation in Belgium. So, being a small group within a huge organization, we benefit from, at least from the side of quality assurance and QMS, we use very easy this system. Then probably the audience, I'm not sure if it's everybody in dosimetry, specialist in dosimetry. Ionizing radiation mainly deals with dosimetry calibrations, of course, also activities and neutron measurements. There are many places where we find ionizing radiation, like nuclear power plants, research center. A lot of doses are receiving radiotherapy and nuclear medicine, but we have also radiation in mines and ore industry. In 2015, it was estimated that the average dose received per year per one inhabitant in Belgium comes 39% from medical applications and about 9% from industrial application, but the rest comes from the nature. So legally, exposure of workers to radioactivity needs to be monitored in general with dosimeters. And also another direct application, uncertainties on delivered doses in radiotherapy or nuclear medicine are linked to the success of the treatment. So therefore, dosimeters need a traceable calibration, that's metrology of ionizing radiation. And I always say 1 gray in Belgium or 1 sievert should be 1 gray or 1 sievert in any other corner or in any other part of the world. I'll show here some examples of dosimeters. Basically, a dosimeter measures the deposited charge by radiation in a medium and converts it in electric current, charge. This is what we measure. And then we have joule per kilogram, which is gray or sievert. We have ionization chambers, which are probably in dosimetry the best tools to use, different sizes, the farmer type, very small, then plain parallel chambers or like cylindrical chambers. And we usually read the output of these chambers with electrometers. Then we have ambient dosimeters that may have a digital screen, many of them, but some they have a needle analog display. And personal dosimeters that may have no display, and then the user will have to read the output using relatively complex devices. LNK, probably calibrations at SCK were done even before 1995. We had about something like wooden tower. None of us know exactly what was that. In 1985, a new building called CAL on the left side top was built, and it was used till 2021. It was a pretty small, with only 2 irradiation rooms. Then in 2009, we took over radiotherapy calibrations from University of Ghent, and we had 2 sites split by 100 kilometers distance. And because the buildings became old, no more spare parts for the irradiators, in 2021 we had a brand new building, and with 6 independent irradiation rooms, modern irradiators, the latest safety and security requirements, and hopefully the LNK building will be used for at least another 35 years, 2025 plus, I call it. Can you still hear me? Or
yes, okay. We can hear you.
Then, okay, the new LNK building since 2021 has 6 independent irradiation rooms. The first one on the left, it's for neutron calibrations with californium and americium sources. Then we have the radiotherapy room with a cobalt-60 irradiator, and we reserve space for a LINAC that will be probably installed in 2024. Then we have a cesium cobalt panoramic irradiator, an X-ray irradiator with 2 tubes, and a cesium cobalt irradiator with multiple sources. This probably is the most used, many times per day, and it has, okay, in terms of dose rate, has the lowest dose rate, while the radiotherapy the highest dose rate. We also have a room for long-term irradiations with cesium cobalt for radioecology experiments, where we can continuously irradiate for days without any problem. And of course, the control room really in the center, and some office space. The building is located on the site of SCK CEN. Then I'll show a few examples of irradiators. So that's the one for radiotherapy calibrations. The a cobalt-60 source, it's inside the irradiator at the place where you see this light. This is a dummy light to show the beam size. And we calibrate with this irradiator a farmer type ionization chamber. So these are very small chambers like this. We can do it in air, or we can do, as you see on the right side, inside the water phantom, something that some box that simulates a human body. And we do it always in fixed distance, fixed beam size, well-defined conditions. That's one case of calibration. And okay, the ionization chambers are also different shape, but pretty standardized. So I would say this is an easy case to digitalize. Then we have the X-ray dual tube generator. You see the tubes are behind this filter wheels with copper filters and aluminum filters. And then we have a linear positioning system that can be brought in front of one or the other tube. And the distance from the tube center can be also changed. All axes X, Y, Z can be are computer controlled. We have also in this case in the photo an ionization chamber, the black sphere that is placed in the center of the beam, and we read it with with an electrometer. Again, we have a pretty wide range of energies. So in the spectrum, in the graph here on the bottom, you see the fluence spectrum of different beam qualities. These are somehow characterized by different energies. We can say different energies, and of course different dose rates. The third example and the last, it's the neutron calibrations. Again, different from the gammas or the X-rays. We have the irradiator in the center of a huge room, 10 by 10 by 5 meters, because we want to avoid neutron scattering in the walls. Ideally, the neutron sources should be free in air and no walls around, but that's not possible for radiation protection. And the detector, it's placed on the table, this black sphere, pretty heavy in this case, like a few kilograms, and it just has a digital display, no way to connect to an acquisition system. Okay, at least this detector, or not easy. So we have a lot of challenges in having an automated system, automated data acquisition, because we want to be flexible. We have diversity of dosimeter on the market. We have to calibrate really all dosimeters that exist on the market, and we have different shapes, different way of reading. And also we have diversity of methods, and we want to combine everything in one common database with one acquisition software. So we have like 11 calibration methods, or CMCs, because we have neutrons, gamma rays, X-rays, beta particles even. We have 5 quantities. You can speak about air kerma, HP10, A*10, HP07. 2 units, gray or sievert, so always have to choose, and also 5 phantoms. These are artifacts that are used to simulate the effect of the human body. So the acquisition system, to match all these challenges, it's a bit complex. We found a solution, and I don't know how, I'm sure it's not the perfect one. It can be done better. So we have the workflow like that. So we get a device from the customer. We register it to a database. We attribute with giving the type, serial number, and we attribute a unique predefined certificate number. So if the device was already in our lab a few years ago, it's pretty easy to do it. It's just a few clicks. If not, you have to really type it by hand in acquisition software. Then the next step, we perform the irradiations. One record line for each irradiation will be saved in a database. Then we export all these record lines that are linked to one certificate number to an Excel template. It's just a text line that is dropped in the Excel. So all these three steps are done in the acquisition software provided by the manufacturers, by the manufacturer of the irradiators. It's Hopewell Design USA, and it was really customized for us using our workflow. From the Excel, the operators have to select the type of calibration needed from a list of about 14 options. Then to verify the results, print a PDF file using macros. Once the PDF is done, so the operator should verify again, sign, and send it to the customer by email. All the data in the database, it's also useful for invoicing, logbook, statistics. Now, so how the software was done? So the acquisition software from Hopewell, it's written in LabVIEW, but any change has to be done by them. We opted to the simple option of Excel to have the results dumped in an Excel file, because we said Excel it's used a lot at SCK CEN. It's a software provided by our ICT department and maintained, and also changes can be relatively easy implemented by any of us. We also see that this Excel template must be updated and customized many times during the operation. So this is an example of how we really measure. So we have one detector, this ionization chamber, which is sealed. We put it on the table in front of the irradiator. The collimator of the beam is here. The irradiator is the brown cylinder. Then something that complicates the situation, we have a rotary table that allows us to rotate the detector around the z-axis, and then some parameters depend on the angle. We have the table of the linear positioning system, again automated. We have the pressure, temperature, humidity sensors, and the electrometer on the bottom of, we store it somewhere outside the beam. We have also a video camera to see displays in case we calibrate something with display. So on the right, it's a photo of how one of my colleagues is doing the job. So he installs everything on the table, and then with the video camera, he watches the display. But don't think that all the displays are easy to read with a video camera. Some are in very bad shape because sometimes we get detectors made in 70s to be calibrated with very bad screens. So this is a screenshot of we have multiple utilities or apps involved in the workflow. First, we register everything in the database, and we attribute an LNK certificate number, unique and based on the year. Then we have so we go and we start the irradiation. So the software, the irradiator control, allows us to select between a dosimeter calibration and an irradiation. An irradiation is the particular case when we just irradiate, we expose the detector to the dose, but the reading is done by the customer, and we don't provide the reading on our certificate. Then we have multiple sources. We have the different dose quantity, the unit, and also the phantoms. If we use a rotation table, so then the table will automatically rotate to the angle desired and specified by the customer, and automatically the conversion factor from air kerma to the operational quantity is changed according to the angle. All these parameters and also the calibration of the irradiators are included in the database. At the end, we have two databases, the irradiation database that includes all the parameters that are saved during one exposure, one irradiation, and we have the principal one record line, it's one irradiation, and in addition we have we record constantly the pressure, temperature, humidity in every room. And even here there are cases when we need two thermometers inside the room, one to measure the air temperature and one to measure the temperature in a box of water, in a water phantom. And then, of course, the challenge is if you want to calibrate in terms of water or in air, the proper thermometer has to be selected. So all these were implemented in the Hopewell database and in the Hopewell server. The temperature, pressure, humidity at start and stop of the irradiation are also saved for each irradiation. Then things become a bit simpler. So we, with another tool to generate the report, we select one of the calibration certificate that we are of that interest, and we export everything to the Excel file. So, okay, it's actually only the report utility written in LabVIEW, then Excel templates with a lot of macros behind, which tends to become a monster, Acrobat macros, and then we create the PDF that is sign and lock. The Excel template, it's locked and only a few fields are open for selection to the for the operator. And of course, the operator has the chance to, for instance, in our case, to select the language for the certificate. We offer that as option Dutch, French, and English, depending on the request of the customer. And also, for instance, the operator should select if temperature, pressure correction it's enabled. If the certificate falls under the ISO accreditation, then everything should be changed, like logo on the certificates should be updated. If the reading is manual or automated with electrometers. So all these parameters have to be every time selected by the operator. And it's really a puzzle to program everything. So in the workflow has some challenges. So for the moment, we have only one type of electrometer that is fully implemented in the acquisition software. Not all electrometers on the market can be easily implemented. And imagine that somebody comes with a brand new electrometer. How do you program it fast and link it to your software? The manual reading is always needed and may not be easily replaced. Digital screens are available, but no possibility to connect to the dosimeter. Digital screens are in bad conditions, like odd models, broken screens, light reflection, it's always a problem. You may have analog devices with a needle. Then luckily, we have all the method revalidation measurements are performed automatically. That's very easy to standardize. And we still have raw data from 3 CMCs that are outside of the database. So we have to use Excel templates, independent templates for these CMCs, like radionuclide calibrators for nuclear medicine. And here we have the issue like we may perform the calibration on site of the customer. So we have only one laptop with us. Surface contamination monitors, not easily linked because you have to really read them manually, or beta calibrations. That's about the acquisition software. In several years ago, we had also a refurbishment of the document storage, the integrated management system at SCK, and this will be in detail explained by Geert. LNK being small, really use the advantage of a huge organization to organize everything. So all the documents are stored only in cloud-based application or solution, where at the level of SCK, predefined folder structure with 2 levels was given to every process within the institute or every department. Backup and multi-versions are stored. Of course, when you come with something standardized and imposed on the full organization, interface with data acquisition software that may be difficult, or our system is not very well suited for large amount of data and uncommon data files like raw measurements, binary executables. Then the EMS. So we have the advantage of a nice portal that it applies for our process. It's just a process that it's independent of organization of SCK, and it's called process 187. The EMS groups quality, safety, security, economics, and environment, and all activities of LNK are grouped on only one process, and we have multiple tools for that. The advantage of the system is that also our procedures and validation files now were recently reorganized, because also we had a new building, so we had the chance to reorganize everything. So we went with the approach like one validation file and one work instruction for each CMC or installation that may end up with big files, text files, but you have all the data in one place. And the work instruction includes also safe operation of an installation, which is required by the safety department, and also the real operation for calibration itself. And what I also like, that the versioning of all our QA documents, it's automated with minor and major revisions, and all the changes are automatically included in the PDF file that it's created. So it's easily auditable. All the documents are easily auditable. Okay, so what we can do next? What I would dream, so if I would do it again, to have this acquisition software, digitalization. For instance, what we miss, sometimes we place detectors on a phantom and it's a long irradiation, let's say overnight, the detector falls down and we have no proof how it behaved. Or sometimes we want to see how we really position the detector on the phantom or on the table. So ideally, photos taken at the start of each radiation should be done automatically, and then the storage place in the database should be linked to a certificate number. That will be a nice feature. Automated reading of the screens from any detector. Then you will avoid that the human error when the operator really types like 10 readings from dosimeter. Web interface for ordering the calibrations from customers. Now, okay, the customer will call us, we discuss a lot how to do it, and then we introduce by hand everything in our database. In principle, the customer can do this himself. And also communication with the customer can be done in the portal. Delivery of certificates, probably customers' feedback can be implemented as well. But again, many times our customers are calling and we have long discussions how the calibration or the irradiation can be done because it's something customized. QR codes printed on the calibration labels with direct link to the calibration certificates on the server of LNK. So now we have QR codes on our instruments for the recalibration or maintenance calendar. So these QR codes send us directly to the lab tool application that reminds us about calibration. User accessible calibration factors for ambient sensors. We monitor pressure, temperature, humidity. We typically verify them against a calibrated instrument, but we also can take them, take them out, send them to a calibration lab, and then put them back. But if they deviate, we don't have an easy way to introduce a correction factor. So we have to recompile the LabVIEW software. So from my point of view, automation is the key towards efficient work and low risk of errors. But we should always keep flexible to accommodate everything on the market and to be able to change in case we need it. So that's a big dilemma. Thanks a lot for your attention and questions, and will be welcome probably after the presentation of my two colleagues.
I'm Leen Verheyen. I work in the lab also at SCK in the group of LRM. It's a group of low-level reactivity measurements. And in this group, we measure alpha, beta, and gamma radiation. We do sampling and sample preparation, and we do alpha and beta global measurements. We have a LIMS that works for, let's say, the whole groups. So for a little bit, it covers the whole group. So it's implementing the orders and the samples, and then the samples goes and the samples goes to the labs, and there they are distributed. So I'm going to focus me today on the lab of gamma spectroscopy, because that LIMS implements also the measurements and analyzes. But there's also overcoupling LIMS for the whole group. So I will start a little bit about the lab of gamma spectroscopy at the SCK at LRM. What is a LIMS and why we use it? I think you will hear that today a lot. The gamma analysis process flow and the management in the LIMS system. So that implements the sample registration, spectrum acquisitions, the analyzing operations, so all corrections needed to be made in every analysis, and the reporting of the sample to the customer. A few parallel processes which are implemented in the LIMS I will also see. So the QA, QC and background measurements are implemented in the LIMS, and our communications with the clients, and a few conclusions. So at the lab of gamma ray spectroscopy, we have in total 20 high purity germanium detectors. So to give a little bit of an overview, the detectors are all different. So they have all different specifications, all different efficiency curves. So it goes from low energy high purity germanium detectors to regular coaxial high purity germanium detectors. We have a LEGI, germanium lithium detector, a well type detector, so they are all very different. The efficiencies for people who know something about it are vary from 10 to 80%. And all the systems are connected to a links of Miriam, so the digital signal analyzer works all the same. We have not something special for some detectors, they are all the same. The filling of liquid nitrogen for the high purity germanium detectors, which is necessary, is an automated filling system. So that works with the PLC, and it starts weekly automatically, and we don't have to do anything about it. We only check if they are really full. And to be sure that they are full, we are working on a weighing system under each detector, which will also be connected to an Excel where the weights will be implemented in the future. But I'm not going to go deeper on that part because I already think I have enough in this presentation. To give you a little bit of an overview what samples we measure, 60% of the samples are from the Radiological Environmental Monitoring Program, which we are doing for the FANG, the Federal Agency of Nuclear Control in Belgium. So that are water samples, milk samples, food, feed samples, soil, vegetables, plants, and so on. They vary a little bit, but also air filters, and they are distributed about over the whole Belgium area, or the Flandern area. Then we measure also samples for radiation protection. Those samples are coming from the power plants or from our own BR2 reactor, and are a little bit to check the process of the reactor if everything is going okay. We have samples for import and export of animal feed products. We have a lot of norm samples, which are naturally occurring radioactive materials coming from different firms and different places. We have samples for food control, and internally we measure a lot of samples for scientific research. Our lab measures about 3,000 to 3,500 samples a year. And for the measurement, we use different geometries. So you see at the picture, there are a few just cylindrical, volumetrical samples, but also a Marinelli beaker. We measure cartridges, filters, point sources. It depends what the customer wants, we can measure. Weekly, we do a QA measurement on each detector. So we have about 20 detectors. So that's 20 QA measurements. And we do the energy calibration also then again. And we do monthly a background check. I have to admit, it's, I think, more every 5 or 6 weeks we do a background check, because otherwise we can't measure everything. The samples are also measured overday, overnight, or during the weekend, so they have to measure pretty long to get the good detection limits. We are accredited, the lab is accredited, so we have a ISO 17025 and 14001 for environmental lab activities. The calculations happen within 2 programs, or with 2 programs. So we use Gini 2K from Miriam, and for every sample or every measurement, every sample, we do an efficiency transfer with FTRAN, and we do a summing correction within Gini. So those 2 programs are implemented in the LIMS. What is now a LIMS system, and why do we use it? So it's a laboratory information and management system. It's software based, and yeah, it keeps information management system. Yeah, it keeps information together. Key features include the workflow. So it implements, it's making the workflow easier. It's making it easy for data tracking. So if I want to look something up of a long time ago, it's much easier with the LIMS system. When you make or want a LIMS system, it's always good to have a flexible architecture, so you can change things, because our LIMS already exists since 2009, and yearly we adapt things, we have to change things. We get new radionuclides or new decay, extra things to implement. So a lot of things change every year. And it's also always good to have smart data exchange interfaces. Then the software should fully support its use in regulated environments. So that's also important for the LIMS. Why using a LIMS? I think most of you know that already. So you do an automation of an analyzing process. So if the interfacing is good, you get a good output. Also, you get a good overview about the samples or orders. We reduce user input. So the spectrum management is done within the LIMS system, so we can't make errors there. The selection of efficiency calibration background files and the analyzing parameters are automatically implemented in the LIMS. It increases throughput. So you get more done in less time, or you need less personnel. It improves quality. We do a quality check. It's also implemented in the LIMS, so you're sure there are no errors of writing or something. And you have the same process for all analyses. So I make the habit of not measuring something fast. I always put it in the LIMS, so I can track it. I can see that everything is done correctly if the data are in the LIMS. Yeah, and we have a system of data management. So our calibrations, when I make a calibration and I see that or the detectors has a problem and afterwards the calibration is not valid anymore, I can think it off or put it off and import a new calibration, but I still can see what calibration I used in the past. So that data management is also important for a LIMS system. The spectra and analyzers are coupled. The QA data you can follow up. We have a hardware inventory in the LIMS, so the data of the detectors is inside, and also reports and certificates are of course in the LIMS. The architecture of the LIMS, it's a homemade system, and it's on MS Access made, so the interfacing is with Access. So we start with the spectroscopy hardware. I already told that all the detectors are connected to the links. So you see at the left all the link system stands, and they are connected all with one server PC. That's our backend database, so everything comes on that PC. We have a barcode reader, a barcode scanner, and every sample has a barcode. I will show you later, and every detector has a barcode. So when we start the spectrum on a certain detector, it's already coupled, those two, and you can't get them off each other, so they are together, and you can't make any errors of your efficiency. And then when the measurement is done and so on, the server PC is connected, or the working PCs, the front-end database is connected to all other PCs or analyze on the PCs of the analysts, and they can connect to the server PC of see the spectra, see the data, and they all see in the same database. So you can work on the spectrum with more people together, or you can analyze more, not one spectrum together, but everyone can analyze on the same time. So the application software is Visual Basic. So the gamma spectrum, the flow of the quality data is also very important. So to improve your quality control, so what's all for the sampling inside? So we start with sample reception and registration. I told you already before that happens first in the central LIMS, and then I get the data out of the central LIMS, so the weight of the sample, the reference, in our database. So here are the sample parameters, the client information, communication, geometry parameters, and so on, are together in a form for sample reception and registration. After that, when the sample is ready to measure, we start the acquisition. And like I told you before, the acquisition is barcode driven. So you can make any orders there. There's a detector dashboard to see which detector is running and which one is not. And we have a spectrum management. When the measurement is done, you can start the analysis. So we do for every sample an efficiency transfer, which where the sample is different from the source where the efficiency calibration from is made. We do a background and a summing correction and an appropriate uncertainty calculation. And the approval or rejection is also done after the analysis, and then we can make a report or a certificate. We can put all the results together in a list. We can email directly to the customer. So this is a little bit the same overview. This is the sample registration. So you register all that data, the client, the risk, geometry, quantity, everything, and you can send an email afterwards to the customer with the results of what he needs. This is the form we use for the sample registration to give you an overview. So the first thing you have is an order reference and a sample reference. If there are more samples in one order, it's also possible to view them. You can fill in a reference date or a deposition date. And here you can already fill in a nuclide factor. The nuclide factors are connected to the libraries of Gini. And the libraries are also made in the LIMS, but that I will show you later. We can choose a file type, a matrix name, and then we go to the sample weight and, for example, the filling height. When the filling height is different than the filling height of our reference sample, it's no problem. We just fill in for every sample the filling height, so we do an efficiency transfer for every sample. So we can really fill in a lot of data here. We can say if it's a routine measurement or a quality control measurement or an intercomparison sample, and we can print a barcode for the order and print here a barcode for the sample. So then we are at the automated acquisition by barcode. So when there is a barcode on the sample, we can scan it. We scan the barcode on the detector, and it will start measuring in Gini without doing anything. When the measuring time is finished, our server PC will automatically save the spectrum with the sample name, and it will be saved actually just in a table, but next to the sample and the sample name, the detector reference or the number of the detector, and then we can go to the LIMS and connect the sample with the correct efficiency curve. So this is the dashboard. So you have all the links, and you can see at the detector acquisition panel which detector is measuring the reference. Here you can see, I don't know if you can see it, below detector 24 is the reference date and hour, or the starting date and hour. You have a preset time that you can also stop the detector whenever you want, and then it saves also the spectrum. And there is at the right, with the green little boxes, the QA diagnostic indicator. So if the quality control measurement says the frequency is 1 week, it will become red when it's over after 7 days and there's no QA measurement done. Also the same for the background. And when a detector is not okay, when we have to do an action, when the QA measurement is not okay, you really need to, you see it because the little box will turn red and you have to take action to see what's happening, or you don't measure on that detector that day. The control of the analysis. So after you measure the sample, so after the measurement is done, you start the analyzing of the sample. So we have the spectrum management. And when you then open the spectrum, it will automatically connect the correct efficiency curve connected to the geometry and to the detector, and it will couple that with an uncertainty budget. It sounds maybe a little bit complex, but it's all tables and it works very good. Then also the selection here, and I go back here. So here we selected the gamma 2, the nuclide factor. And here also, so the auto selection of the nuclide library will be based on the nuclide factor you used. And the correct background file is then connected to the detector. And then we will do in the analyzing in Gini, we do a summing correction of the radionuclides who needs that, and then we can do the data transfer to the gamma LIMS. So all the results will be imported automatically into the gamma LIMS. So those steps of the analyzing in Gini will not be done automatically. So there will still be an interactive peak fit done manually, but all the data that needs to be imported in Gini, so the efficiency curve that belongs to the sample and the detector, will be implemented automatically. So this is a little bit the management of the spectra view. We can filter on order or sample, or we can just look which samples are analyzed during a certain period. So that can in the tab above, and then you see the order, the reference, the detector you see here, at the right side. And then you also, when you click the Genie 2000 button, it will automatically load the correct reference efficiency, which belongs to that detector together with the file, and it makes corrections. It will load the correct background, and it will load the correct nuclide libraries which belong to that sample. So this slide is pretty, what all happens when you press the Genie button. So it's a little bit of a together of a lot of programs. So everything is stocked, or how do I say, into the access data bank, into the LIMS, but you will get a lot of data out of Excel, or calculations with FTran are also done in Excel, because FTran is an Excel-based program. So you have the sample container parameters. So we have default sample data, and they have a certain uncertainty budget for that sample. You have the detector model data, which also have the reference efficiency calibration connected to that model. Then when you implement a specific sample data, so the net weight, the volume, the composition of the sample, you have a different sample than the default sample data. And FTran will then start to calculate and give me correction factors, so the efficiency calibration can be corrected on the correct way. So can be corrected, and we have a good efficiency calibration to work with. The efficiency calibration is made with multi-gamma sources, and they have a fixed volume and filling height, and they are always water matrix, acidified water samples. So that will be used. For the then most of the samples are not water-based, so we have a material list, and there the sample composition will be corrected with the XCOM data. So we have a correct mass attenuation coefficient for each material used. And on that way, on this structure, every data will be correctly implemented in Genie. And this is done all automatically, so you can't make any human errors, except when you load the wrong efficiency calibration or so on, but that's always checked double. So when we done, for example, here a sample analyzed with Genie, this sample is analyzed, so all data are loaded. We can just choose a save to database, and when we have done that, all data out of Genie, so all nuclides found in the spectrum will be transferred to the gamma LIMS, and the approval or the control of the analyzing process can be done there. So when we press save to database, it automatically, then we are here after the spectrum analysis in this step, and everything is automatically put into Genie. So for example, this is an example of a soil, of a sediment sample. And you get here all the gamma lines which are found in the spectrum with their peak areas, and you can check here again all the data which was implemented into the LIMS. If you take the second tab, you see the detailed nuclide data. So you see all the gamma lines of each radionuclide found. You can see if they are shifted or not. You can see if the values are trustable, and what you can report. Because this is a norm sample, or there are a lot of norm nuclides inside, we usually use daughter nuclides to determine the activity of the mother. So we have a reporting tool where we can see all the daughters of some nuclides, and we can put the mother on a report, because the daughters are calculated on the half-life of the mother. And we can choose to put once the radionuclides that arrive, for example, radium-226 on the report, and not the daughter nuclides, but just the mother. The reporting can also be done directly out of the gamma LIMS. So we choose the nuclides which the customer wants on the report. And then we have the report management. We can create PDF reports and certificates. We can edit the certificates. They are important from customers who want certificates for the animal feeding products. We can create an Excel list for the reporting, and we can, there stands here emergency, but in meanwhile, while a lot of customers ask for an Excel list, and then we can directly email only when approved, when the measurement is approved, we can email it directly to the customer. So this is how the reporting management looks like. You have normally more here. You can preview the report, make a PDF, or make one report per sample or one report per order. We have a certificate creator. We can add a comment to the report. We have a version management. So when someone sees that a report was sent wrong or there needs to be an adaptation, we can change the version and add a comment on the report. We can create an Excel report per client, per period, and we can send it by email to the correct customer, which is also in the data bank. So the report looks like this. And we can do different formats, so Excel or XML formats, whatever the customer wants. So this is, for example, the email that will be sent them. And this is the Excel format, so we can get this out of our gamma limbs and then export it to Excel. The quality assurance is also in the gamma limbs, so we weekly do a QA measurement on each detector. So that's a lot of measurements, and we can reload then for the 4 most important gamma lines in the gamma limbs, and the detector will become red when it's not good, and then we can take action, look what's wrong. The same with the background check, and the same for proficiency testing exercise. So this is, for example, the background. We then follow up a few important background lines of that detector, and we see that there are no outliers, or we see that we have nothing extra on the detector, or more or less potassium 40. That happens sometimes. So we see that everything is okay with the detector. The same for the registration and evaluation of proficiency tests. The registration happens the same way as the normal samples. So we try to do nothing special for proficiency tests. And then we can implement the results into our gamma limbs and look to the zeta scores or the Z scores, make a draft out of it, whatever we want to do with this, and check that on that way that the process is still okay. And then another important thing is the management of nucleide libraries. So like Romain said in the first presentation, it's important to have correct nucleide data. And if someone knows Gini, you have to type in all nucleide data yourself. So it's very easy to make an error. Certainly when you have to implement 100 or 120 nuclides. So we have chosen to use the recommended data of the LNHP. So we have a nuclide, so we have a reporting vector for every sample, and that vector is connected with a CAM file, so a Gini2K library, and the library is made out of nuclide data. So I will show you here. So this is the website of the LNHB. You can see whenever the nuclide data is updated. So I try to check that every year. So I always have the most recent nucleide data, and then I download the L file, the ASCII file, and I put it in a notepad file, and I can load the notepad file actually into our gamma limbs. And when I have loaded it into the gamma limbs, I can make a nuclide library with all nuclides I want and with the correct nuclide data without typing over the data which I need.
Sorry, Leen, I have to interrupt, but your time it's.
I'm at my last slide.
Super.
Super. Okay. And then my conclusions. LIMS will improve your analyzing process and work efficiency. So it works very easy. The automation via dedicated interfacing, it helps a lot. It minimizes human blunders or errors in data treatment. Assures the same level of quality for all samples treated. And you get the confidence of what you report. And it's easy to verify all options or see that nothing went wrong. You increases your throughput, you simplifies methods. It's easier to train operators when you have a LIMS systems, and yeah, it makes everything more flexible. The only disadvantage is that you need to make adaptations where needed. It's not something that stays and stops, that you have to stop working on it. I think that was my presentation. So if there are any questions.
I'm going to talk about, by the way, I'm the QA manager of SCK. I'm going to talk about applications and digitalization we have done in other processes, non-laboratory processes at SCK. First, small information about process descriptions. Then something about Connect. Connect is our system where we manage our trainings and competences and qualifications of people. We try to implement applications we use in as little different platforms as possible. So Impact is a platform we use a lot for many kind of applications. And then to conclude, some future work where we have noticed we have to work on in the years to come. First of all, EMS is the integration of safety, environmental quality, security, and strategic aspects into one management system instead of different management systems for each topic. Integrate them into one management system, and this integration started at SCK CEN about 12 years ago. Process descriptions, you have heard Christian and Leen talking about their process. At some slides they have presented the flow of their process, starting from a request from a customer, samples coming in, or data acquisition, and then some calculations, and then finally creating a report and sending the report to the customer. So that's their process. These process descriptions, we have them published on what we call an IMS portal. So each process has a portal where you can find lots of information about the process itself. I'm going to say something about our document management system, and then to finally make the introduction to applications in general. Process descriptions, metrologists probably know the ISO 7025, which is the most common standard for laboratories. It is said in those standards that a management system should be looked at with the process approach. It means you have to describe your activities process-wise. And at SCK, we describe them in our IMS portal. I will have an example on the next slide. That means that we have there standard operating procedures for each process, a process flow, process model. We also perform a risk analysis for each process, and of course, many processes have instructions, guidelines, and other kind of types of documents. Most of the information are documents, but there's also possibility to link databases or applications to the processes from the starting point of an IMS portal. We have about 6,500 IMS documents for the moment, and distributed between 150 processes. This is how our IMS portal looks like. So each process, also the processes of the two speakers before me have, for their laboratory, which is also a process, they have one portal or more portals if it's divided in different processes. Of process has a unique number, but here you can find the process model. There's an example in one of the next slides. It's a layout of the flow. It's built in Microsoft Visio. I think you all have seen such things. And then there are quite some documents, like I said, a procedure or instruction or supporting documents or forms, training documents. There's all information describing how the process has to be carried out. Important for the process is also to know who can perform all these activities. Not everybody can perform the activities in a process. You have to be qualified. You have to have the correct qualifications and the correct competences. It's very important in metrology. There's also a white tab where we put the risks linked to the process, where we speak about or we list the legal requirements. We list the standards and policies related to the process. There's a definition section here where we can, if within the process there's a list of definitions to make it clear what we talk about. To have a uniform understanding of certain terms or abbreviations, we can list them in this database. But very important is this section. These are all applications related to this process. From the portal, we can start applications. The example here is for access control to the site of SCK CEN. It's in Dutch, but no matter what, here you can start through this link. You can start a request to have a visitor to the SCK. Yeah. So that means applications can be reached from within the portal. The global concept is that this portal site here is some kind of a website of the process, and all information should be found through this portal site. In general, IMS document management, we use the LiveLink platform. Internally, it's so common that sometimes forget that it's not a uniform term. We call it our Alexandria library. It's a document management system. Besides the process descriptions, like I showed in the previous slide, processes also have registrations. They are also managed on this LiveLink platform. If you perform projects, they also write reports or meeting minutes or whatever kind of documentation. They are all managed within this LiveLink platform. It's one platform at SCK, and everybody is obliged to use it. Yeah? There are no other systems allowed. That means that everything is organized through this LiveLink platform, which has a lot of advantages because we have metadata attributed to documents like the author, the version, reference number. We keep track of all older versions. There's a complete traceability of changes. We always know what was changed from one version to the other. We can even see who has consulted documents and so on. Very important also there, and that is linked to the topic of today, digitalization. We have automated workflows for approval and review of these documents. And when we approve a document, you get a cover page as follows. where we have a cover page, and you have on top here some reference numbers, some metadata, the revision, and so on. You can see the author, you can see everybody who has approved, the date of approval, and the change log from version to version with some small text what was changed. Challenges for processes we have experienced in the past 12 years. As a matter of speech, not everybody wants to expose their knowledge. Fortunately, most of them do, but we have met people who have built up a certain knowledge and they are not very keen of sharing that information and putting it on such an IMS portal system. They often say it's my process, it's my knowledge. That's maybe not correct because it's knowledge of the SCK CEN. There's also conflict between the hierarchical approach and the process approach. We come at SCK, we come from a very typical hierarchical structure, and now processes are transversal. They go completely, not all processes, but a lot of processes use people from different groups in the organization, and then sometimes get conflicts. So working with the process approach is another culture and another mindset is needed. What's the situation at SCK now after 12 years? Most of the processes are now documented, they are described. We know exactly how they are performed today, what you have to do to follow the process correctly. And now we know that. Now we have a starting point to start optimization, and we want to make our processes more efficient. It's a time-consuming effort. It takes a lot of time. That's our experience to come to the situation where everything is described. We are a company with 150 processes. That's a lot, and it will take quite some time before there are a lot of efficiency is brought into those processes as well. Processes and applications. Very often, and you also saw that in the previous presentations, not all processes, but a lot of processes benefit from an application. The activities in a process can be converted to some kind of a workflow. Maybe not a complete process, but at least parts of a process can be automated in a workflow. Some kind of you can call it some kind of a business intelligence. And it's also already said in the previous presentation, I've heard it several times, limit personal errors. That's a goal, because we have seen that lately through these applications we see less errors in that. The goal of these applications and describing processes and going for a process approach is we perform the activities to produce an output that meets the customer requirements. And not only doing this once, but if you are a routine laboratory or you do a routine activity, you have to do it over and over again, and each time in the same way. The goal is also to get a higher efficiency, so we have to improve and we make our processes more lean, and there's also the application. But, and also Christian mentioned it in one of his slides, it's not black and white. Don't forget the face-to-face discussions. They're important because during these discussions, brilliant ideas can arise. Human interaction is still very, very important. And you can create applications where everything is so rigid and nobody can, yeah, there has to be some flexibility as well. There are technical processes, and we have seen the two examples of a laboratory, but there are also business processes which are valid for a broader audience, for a broader group of employees at SCK. And there we use applications. One everybody knows, I guess, is SAP to manage the orders, invoicing, budgeting, and so on. We also have an application to manage the access control to the SCK CEN site, and that is used by our guarding group. Nuclear material accountancy uses an application so they know exactly the movements of each nuclear material, and so on and so on. The processes which are important for an integrated management system, I will present some examples in the next slides. But first, what are the challenges with applications? You need IT support because it's easy to say, okay, we'll build an application, but you have to maintain it. It has to keep on working. If there is an incident and there's the application is offline or doesn't work anymore, yeah, you have to be able to fix it. If processes rely completely on applications, I would say fine, but be aware they have to stay up and running all the time. What are the risks if a process application doesn't work anymore? Is it okay if it breaks down for 1 hour? Can we wait that long, or is it not acceptable? Avoid a huge number in different platforms used. Otherwise, you get such a broad landscape of all types of platforms that your IT department will get crazy and cannot manage it anymore. It's also important that these applications, they are well managed and that they are not knowledge of one person sitting in the lab and making his hobby of creating software specific for this laboratory work, because this person in the end will disappear from your company or from the lab, and make sure that this knowledge is shared. So pay attention to that. If you work with external providers, service level agreements, of course, are very, very important. What you expect from them to keep your system working. Eventually, you may need backup scenarios whenever an application fails. Suppose the LIMS system of Leen Verheyen, the previous presentation, suppose the LIMS system is down. And it's not down for 1 day, but for a week. And they call somebody, or if it's internally and it seems not such an easy problem, what happens then? Can we still measure? Can we still send something to customers? All questions where we have to be aware of. Also very important is user acceptance, user support, user training. If it's an application for a broader audience at your company, this is very important. An example of such an application is, it's a name we give it at SCK, it's Connect. ISO 7025 accreditation requires that you qualify, for example, you qualify the operators by setting up the competences they need to do some activities. And if they succeed and receive the necessary training, then they are qualified. This is such a process flow. I've talked about. Each process needs such a process flow. It's called a swimming lane model, but that's not the main point here. You see that there are, all the boxes are activities. You cannot read it, but that's not a problem. So there are activities, something that needs to be done. And here at the side, you see a role, a coordinator or cannot read it, supervisor or an operator has to do this, and the coordinator has to do that. So this role requires other competences than this role. And that is what is organized in our Connect system. Processes are based on roles. And if you meet those conditions, if you meet those competence requirements, you can be qualified for that. And all the trainings given to the people, they are also registered in that system. If your qualification is about to expire and you need a certain training, then this application Connect will give you a warning, and then you have to go on training, or can be an on-the-job training, or read an instruction again, and then or do a test, and then you're qualified again. For example, in Connect, you can see your own competences. These are my competences for the role QA manager. You can see that I have to follow an e-learning. I have to do an on-the-job training here, and I have to be trained for Visio because I need to be able to create those process flows and the date from my last training. And luckily, I have succeeded in all those trainings, and that's why I am finally getting the role and I'm qualified as a QA manager. I can also see the competence of my team, and you see that these people here are 100% qualified for this role. But this person is new, it's in red, and I see that I need to train her to get the qualification. Impact, it's our platform where we manage quite some different applications, and it's only one platform, and the most important application is pro-reactive management. And pro-reactive management, it's an application for events like incidents, non-conformities, improvements, complaints, and typically you register a non-conformity, then you look for a root cause analysis, you follow up the actions, and then finally you see if it's effective, yes or no, and then you close the event. These events, they can come from day-to-day observation, or maybe as a result from an audit or an inspection, or maybe as a customer complaint or whatever. Also there, automation helps, because if somebody registers an event, a workflow starts and the right people at the right time are involved and need to perform some actions and investigations and finally close the event. This is an overview of this impact platform, where you can see that also compliance management is an application here. That is the gap analysis we perform against some standards or some legal requirements to see if we need to take some actions, if we have a gap, yes or no. If everything is okay, fine. Otherwise, we have to take some actions. Somebody has to do it, register that, and finally close the action, and the gap is closed. Management of change, just to give you a few examples, is also a process, and management of change is like organizational changes within the company. If in an installation you are going to make an important change, then you have to log it, you have to register it, you have to describe this change, budget, time, and so on. And somebody has to approve it depending on the change you want to make. And finally, when the change is done, everything closes again, and that's it. So you see, all these applications, they really support the flow of different processes. Future work. We have done a user adoption tour now, and or last year. And what was the outcome? We have talked to different groups of employees. The outcome was that applications should be made more user-friendly. That's what people expect. And it seems that, quite some of these applications are experienced as not user-friendly enough. Processes should be made more simple. It's maybe not only the application which is too complex, but maybe the processes need to be more simple and more efficient. But it was also said that the transition that SCK CEN made towards a process approach supported by these applications is a good thing. And it's a general acceptance, and even most of the people we interviewed, they wanted a high level of standardization. They clearly needed, they clearly wanted instructions, what to do, and not going to search it on the IMS portal and read an instruction, but they wanted some guidance through an application, step by steps, so that they did the right things. And information should be easily found by the search engines was also a remark. So that's a bit what we did on an SCK CEN higher level with general processes, and how we think that applications there, and you can call it digitalization, also is very important. I think this was the last slide.